Welcome to our exploration of extreme weather events and the multifaceted factors driving them. In this video, we'll delve into whether climate change is the sole culprit behind these intensifying extremes, or if other natural and human-induced changes play significant roles. From natural variability and land use changes to urban heat islands and pollution, we will unpack the complex interactions influencing our climate. Join us as we seek to understand the intricate web of influences that shape our weather patterns today. 1. Climate change amplifies extremes. Climate change, driven by greenhouse gas emissions, is undeniably intensifying many types of extreme weather. The heat waves we experience today are hotter and more prolonged, while droughts seem relentless. Moreover, storms, fueled by warmer temperatures, are more powerful and destructive. Think of it like turning up the volume on a radio. The music, or in this case, weather, remains the same, but its intensity increases. This amplification means that areas previously accustomed to mild weather conditions are now facing unprecedented challenges. However, while climate change is a significant amplifier, it doesn't act alone in orchestrating extreme weather events. 2. Natural variability. The Earth's climate has always danced to its own rhythm, experiencing natural fluctuations over time. Phenomena such as El Niño and La Niña are examples of natural climate patterns that can influence global weather. These patterns can sometimes lead to extreme weather events, like altering rainfall distribution or increasing temperatures in specific regions. It's similar to how seasonal changes can affect our day-to-day weather. While climate change is a constant background factor, natural variability adds layers of complexity, occasionally leading to severe weather conditions. 3. Land use changes. Human activities, particularly those altering land use, significantly impact extreme weather events. Deforestation, for instance, removes trees that naturally absorb rainwater, increasing the risk of flooding. Urbanization, with its concrete jungles, disrupts natural water flows, leading to urban flooding. In regions where forests once stood, landslides become a more frequent threat. These changes are like removing the brakes from a speeding car. They heighten the risk and severity of extreme weather events, especially when combined with other factors like climate change. 4. Urban heat island effect. Cities, with their dense concentration of buildings and pavement, tend to be warmer than surrounding rural areas. This phenomenon, known as the urban heat island effect, can intensify heat waves, making them more unbearable for city dwellers. Imagine a city as a giant heat sponge, absorbing and retaining more heat than the countryside. This effect is exacerbated by human activities and infrastructure that generate additional heat. As cities expand and more people move into urban areas, understanding and mitigating this effect becomes crucial in managing extreme weather impacts. 5. Aerosols and pollution. Air pollution, including aerosols, plays a sneaky role in weather patterns. Aerosols can affect cloud formation, influencing precipitation patterns and potentially contributing to both droughts and floods. They act like tiny mirrors, reflecting sunlight away from the Earth, which can cool temperatures and alter rainfall patterns. However, this cooling effect is not uniform and can lead to imbalances in weather systems. Pollution's impact on extreme weather is complex, intertwining with other factors to create unpredictable outcomes. 6. Jet stream changes. The jet stream, a fast-flowing river of air high in the atmosphere, is a key player in determining our weather. Changes in its pattern can lead to prolonged periods of extreme weather, such as extended heat waves or cold snaps. It's akin to a conveyor belt that guides weather systems across the globe. When the jet stream meanders or stalls, it can trap weather systems in place, leading to persistent and severe conditions. Understanding the jet stream's role is essential in predicting and managing extreme weather events. 7. Ocean temperatures. Warmer ocean temperatures are not just a concern for marine life, they have far-reaching effects on global weather patterns. These warmer waters fuel stronger hurricanes, making them more intense and destructive. Moreover, changes in ocean temperatures can influence broader weather patterns, contributing to extreme rainfall or drought in various regions. The ocean acts as a massive heat reservoir, and its influence on weather is profound, further complicating the relationship between climate change and extreme weather. 8. Feedback loops. Climate change can trigger feedback loops that accelerate warming and intensify extreme weather. One example is the melting permafrost, which releases methane, a potent greenhouse gas, into the atmosphere, further warming the planet. These loops are like a snowball rolling down a hill, gathering momentum and size as it goes. They create a cycle of warming that can lead to more severe weather events. Understanding these feedback mechanisms is crucial for predicting future climate scenarios and mitigating their impacts. 9. Data and attribution studies. Scientists are increasingly using attribution studies to determine the extent to which climate change has influenced specific extreme weather events. These studies are akin to detective work, piecing together evidence to understand the causes behind extreme weather. By comparing current events with historical data, scientists can assess the influence of climate change on specific incidents. This knowledge is vital for developing strategies to mitigate and adapt to future extreme weather challenges. 10. Complex interaction. Extreme weather events are often the result of complex interactions between multiple factors, including climate change, natural variability, and human activities. Entangling these contributing factors is key to understanding and managing extreme weather. It's like solving a puzzle where each piece represents a different influence. Recognizing the interplay between these factors allows us to develop more effective strategies for mitigating the impacts of extreme weather in a rapidly changing world.